Okay guys, we are going to learn what is the relation between Cartesian, cylindrical and spherical coordinates. First, you are familiar with Cartesian coordinate system. Here is the origin x-axis, y-axis, z-axis. This distance is called as x-coordinate, this distance is called as y-coordinate and this distance is called as z-coordinate, the point for the point P. And that's why many times it is rectangular coordinate system also, or also called as rectangular coordinate system there. Now we are coming to the cylindrical coordinate system. Consider the same x-axis and y-axis. Here, this is the we make x-axis as the initial line, angle made with initial line be phi, and the distance from this point O be equal to rho. Now we have to imagine the point P rho phi z in the space. The same thing is there, just height is added as the z-axis. Means this system is rho phi z, where rho phi is the same as r theta in Cartesian in polar coordinate system, and therefore the relations between spherical and cylindrical Cartesian and cylindrical coordinate system here: x equal to rho cos theta, rho cos phi, y equal to rho sin phi, and z is same as z, and therefore reversely rho square equal to r square plus y x square plus y square, tan phi equal to y by x, and z is same as z. Means rho and phi act as a r theta. In two dimension we say xy to r theta, Cartesian to polar. Yes, in cylinder we are added the height of the cylinder here. Just now spherical polar coordinate system. And in spherical polar coordinate system, we have to consider a sphere. Three-dimensional sphere is there. We divide a three-dimensional space into set of coordinates of sphere, concentric spheres centered at origin, rays emerging outward from the origin. Start with the point xyz here in space. Now, measuring the distance r from the origin, locate it on the sphere of radius r centered at origin. Here we are located. Then what we do? Next we find the way to describe its location on the sphere. We use the method of longitude and latitude on the surface of Earth. Find the north pole, and this angle we call that as a north angle starting from polar angle, we'll say angle made from north pole, and clearly this angle will be 0 to pi at the most. Next we draw the horizontal circle on the sphere that passes through the pole, passes through that point, and imagine the circle here. Drop it in the x, y, z. Then usual rho and phi will use. Phi is the angle made with positive x-axis, and there is r etc. is there, r theta and phi will give you the spherical coordinate system. Please note that notation is not at all the standard. It varies from author to author in very discipline, etc. Now, what is the relation between r, x, y, z and rho phi z? Rho acute angle theta, hypotenuse r and legs rho and z. It follows that sin theta is equal to rho by r, z by r, and rho by z, tan theta. What happens if theta is not acute? Cos theta is negative and z is negative. X equal to rho cos phi, x equal to rho cos phi, that is r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to z r cos theta. And in inverse way, r is equal to root of x square plus y square plus z square tan theta, and so on. These are that gives you the the relation between x, y, z and r theta phi. For example, you see, find the spherical coordinates of this. Answer will be, and the cylindrical coordinates of this. Answer will be this. Try out these examples. Next, what is the nature of theta, which depends upon z? If z is 0, theta will be pi by 2 shown here, which will be line xy plane. When z is equal to infinity, theta will be 0. When z is in minus infinity, theta will be pi. For z is positive, theta will be acute angle. When z is negative, theta will be abscess angle. Nature of phi depends upon xy. In first quadrant, phi is less than pi by 2. In second quadrant, it is between 90 to 180 degrees. In third quadrant, it is pi to 3 pi by 2. And fourth quadrant, it is 3 pi by 2 to 2 pi. The 3D coordinate system, the review. Distance formula between 2 points is given by this midpoint formula. Here AB midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2, z1 plus z2 divided by 2. Centroid of the triangle. Centroid of the tetrahedron having 4 points. Now we'll see direction cosine of a line which makes angle alpha, beta, gamma with positive coordinate axis as is shown in the figure. Then L is denoted by cos alpha is denoted by L, cos beta is denoted by M, and N cos gamma is denoted by N. These are called direction cosines of the line passing through origin. If point A is xyz on that line and OA distance O is R, then the direction cosines of OP are LMN, then direction cosines of that line are LMN, then x is equal to LR, y is equal to MR, z is equal to NR. Again, L square plus M square plus N square equal to 1. Direction ratios of, suppose direction ratios are the numbers ABC, then we can find direction cosines by using that formula, because the direction ratios are the points proportional to directional cosines. Hence, direction cosines from direction ratios, we use this formula. Next, direction ratios and direction cosines of the segment joining 2 points AB are given by x2 minus x1, y2 minus y1, z2 minus z1. Direction cosines are given by divided by r, that is the length, that gives you the direction cosines. Now what happens? Projection of segment of point AB on the line whose direction cosines are LMN. Line's direction cosines are LMN. Then A dash B dash is given by L x2 minus x1, M x2 y2 minus 1, Z N into Z2 minus Z1. Angle between two lines having direction cosines L1 is given by cos theta is equal to this. If direction ratios are given, you have to make use of combination of direction ratios to direction cosines. Line are perpendicular if L1 L2 plus M1 M2 plus N1 N2 equal to 0. That is, lines are perpendicular if A1 A2 plus B1 B2 plus C1 C2 equal to 0 in case of direction ratios. Lines are parallel if their direction ratios are in proportion. Direction ratios are same and direction ratios are in proportion. Angle between, next PPT, show that These lines are parallel to or collinear. First, direction ratios of A and B are minus 3 minus 2 1. Direction ratios of AC are again minus 3 2 1, and therefore direction ratios of AB and A are in proportion and hence parallel, and hence AB are collinear. Thank you.